I'm on A. Let us consider interaction model in regression analysis. What the interaction model and what is the difference between interaction model and linear regression model. Okay, let us see that. The coefficient beta 1 and beta 2 of a multiple linear regression model with two explanatory variables, which we considered earlier. Let the multiple linear regression model be y equal beta 0 plus beta 1 x1 plus beta 2 x2 plus epsilon. This is a model, right? The coefficient represents the amount by which y increases when each respective explanatory variable increases by 1 unit. Since the expected value of y is like this, I told you this one, expectation of y equal to this part because of mean of epsilon is 0. Beta 1 indicates the increase in y when x1 increases by 1 unit, beta 1, regardless of the value of x2. Whatever x2 takes some value, beta 1 indicates increase in y when x1 increases by 1 unit. I think everybody knows. Suppose, for example, let's take a simple example like this and explain this model and interaction model. Let's say expectation value of y equal to 10 plus 2x1 plus 5x2. Okay? This shows that regardless of value of x2, when x1 increases by 1 unit, y increases by 2. For example, when x2 equal to 1, then x2 equal to 1, then ey is substitute 1 here, then 15 plus 2x1, right? x2 equal to 1, then 15 plus 2x1. When x2 equal to 3, then this is going to be 15. So 25 plus 2x2. Let's see this diagram. x1 here, y here, vertical axis. x2 equal to 1, then what is that? 15 plus 2x1 here, 15 plus 2x1. And x2 equal to 3, 25. This intercept is 25 plus 2x1. The lines are parallel, and when x1 increases by 1 unit, y increases by 2 whenever x2 takes some value. Okay, regardless of the value of x2, x1, 1 unit increase in x1 always raise y by 2, right? However, if the effect of x1 on y varies depending on the value of x2, then an interaction model rather than a simple linear regression model is appropriate. The interaction model is just add this one. So y equal to beta 0 plus beta 1 x1 plus x2, beta 2 x2 plus beta 3 x1 x2. Product x1 and x2, x1 product x2 terms added plus epsilon. All right. In an interaction model, for a given value of x2, an increase of 1 unit in x increases y by beta 1 plus beta 2 x2. Given value of x2, some given value, okay? Given value. Then, what is that? X1. The coefficient of x1 will be beta 1 plus beta 3 x2, right? This much. Likewise, for a given value of x1, an increase of 1 unit in x2 increases by y by this one. So beta 1 is some, this one is given some value, takes some value, then beta 2 plus beta 3 x1, beta 2 plus beta 3 x1 will be the coefficient of x2. Okay? Suppose the relationship between y, x1, and x2 is like this. This is a real relationship between y and the x1, x2. Then we can find x2 equal to 1. Okay? x2 equal to 1, x2 equal to 1, x2 equal to 1. Then 15 plus 2 plus 0.5 x1 because x2 equal to 1. Okay? Like this. x2 equal to 3, 3 here, then 25, 10 plus 15, 25, plus this one is 3, then 1.5, 2 plus 1.5, 3.5 x1. So what? Intercept and slope will be changed depending upon the value of x2, like this. Okay, x2 equal to 1, then 15 plus 2.5 x1. x2 equal to 3, then 25 plus 3.5 x1. Slope is raised up. Therefore, it can be seen the coefficient of x1 varies depending on the value of x2. Sometimes this model, interaction model, is more reasonable, okay, to represent the data. For example, this is a simple example also. A company that manufactures belt has developed a new belt processing method A and B. This is variable x1. What is this x1? This is x1 is a dummy variable because method A or method B. After manufacturing 16 belts using the processing method A and B, shocks it is x2 were applied, and the lifespan of the belt uh, was examined, and the sample data is shown in the table like this. This is the data. Okay, x1 is method A or B, so dummy variable. When A x1 takes 0, and when B, method B, then x1 takes 1. We have to import this dummy variable values. Okay, then x1 is 0, method A, 0, method B, 1, dummy variable. Linear regression model will be y equal to beta 0, beta 1 x1 plus beta 2 x2 plus epsilon. Just multiple linear regression model. Additionally, we consider interaction model like this. Okay, y equal to beta 0, beta 1 x1, beta 2 x2, beta 3 x1 product x2 plus epsilon. All right, let's see the result from this 16 data. For linear regression model, we have result something like this table. 39.7614 p-value is 0. It's a very small value. And beta 1 is a 15.4338 p-value, very small. And this one, x beta 2 hat will be minus 3037 p-value, very small. R square is 0.930, pretty high, R square value. And result of the interaction model, this is the result. So 35.1636 and x1 26.7172 minus 0.2420 p-value small, interaction term minus 0.1527, p-value is a little high p-value. So it means we do not have to consider this one, this explanatory variable, product term. R square is 0.944 because this interaction term is added in the model, so bigger than previous one. In the interaction model, the significance of coefficient for x1, x2 is primarily important. You have to look up the significance p-value, whether this term is good or not, necessary or unnecessary. If it is not significant, it is not significant because p-value is greater than zero point 0.1. There is no reason to apply the interaction model in this case, in this data. Okay? In this example, since p-value is relatively large at 0.113, there may be no need to apply interaction model. However, because the sign of interaction term, sign, is negative, it indicates that processing method and shocks, processing method and this x1 and x2 shocks act oppositely because its sign is negative. That just to give us some meaning from interaction model. When this interaction term has a small p-value, then you have to consider interaction model for your data. All right, it is not that hard, okay? Okay, that's it today. Thank you.